today's class. In today's class, I'm going to take my time to explain to you the different formulas of velocity ratios of different machines. In the previous class, I talked about the topic machine. I also discussed the terms that are used in describing machine, which include the mechanical advantage, the velocity ratio, and the efficiency of the machine. But in today's class, we want to look at specifically the velocity ratio, how to calculate the velocity ratio of different machines. The reason being that different machines have different configuration, and from their configuration you'll be able to formulate a particular formula that is suitable for a particular machine. So already there is a general formula for finding the velocity ratios of different machines, and that general formula is distance moved by the effort divided by distance moved by the load. But based on the way that different machines are configured, this formula will produce as well separate formula for a particular machine. Let us look at the following machines. We are going to be considering an inclined plane, the screw, wheel and axle, wedge, and pulleys. So we'll quickly go to the first one. The first one is an inclined plane, and that's what I do here. This is a simple machine whereby you are using a plank to lift a load and put on top of maybe put on the base of a lorry or to a particular height. So when you are using this simple machine to carry out, to perform a particular task, we want to find out what is the expression for its velocity ratio. So it's very simple. What you are going to do is, let us write the velocity ratio according to the formula we have on the board. Velocity ratio is equal to effort distance over load distance. So effort distance talks about the distance that the effort will move, the distance the effort will move. And let us find it from the diagram here. You are pushing the object from here to this top. So the effort applied is moving in this direction. So this is the effort here. And the effort is moving up. So that effort is going to move a distance that is equal to the length of the what? Plank, which is OB. So it's equals to OB divided by load distance. What is the actual distance that the load is expected to move or to go? The actual distance is from the base of the lorry from the ground to the base of the lorry. So the actual distance the load is meant to cover is the height. The height, because that is intended distance that object is meant to move. You are using a plank to carry out the task, then that's why the load is going through this other distance. So that distance is equal to AB, which is equivalent to the height of the base of the lorry from the ground. So this is a formula we have as velocity ratio. Now, let's go back to the diagram. The diagram we have, when we look at it geometrically, it is a right angle triangle. And when we have a right angle triangle, we can resolve the problem in a right angle triangle using what is called trigonometric ratio. And in the trig ratio, you consider the relationship between the sides, two sides of a triangle and one interior angle. Here, we have the length of the plank and we have the height of the base of the lorry to the ground. So we are comparing it, these two sides, alongside the given angle, the angle of inclination of the plank from the horizontal ground. So in doing that, you are going to see that the relationship, the trig ratio that connects these three things is sine theta. So we are going to take sine theta to be equal to opposite, according to trig ratio, sine theta is opposite divided by hypotenuse, opposite over hypotenuse, which is equal to, what is the opposite here? Opposite is AB divided by OB. Hypotenuse is what? OB, which is length of the plank. Now when you look at this expression, velocity ratio according to the original expression we have earlier is OB over AB. But here, when we treat the sine theta, we have AB over OB. But we need to make this sine theta, this expression here, to be the same with our original expression. In doing that, I'm going to take reciprocal of this function, sine theta. So I will say 1 over sine theta is equal to, 1 over sine theta is equals to, when I take reciprocal of this sine, what it implies that? It implies saying 1 divided by AB over OB, which is the same as 1 multiplied by OB over AB. Simple law in mathematics that when you change division sign to multiplication, the next fraction will be inverted. So OB comes up, AB comes down because I changed the division sign. So it means that my 1 over sine theta is equal to what now? Is equals to 1 times this. 1 times OB is OB over AB. That is to say that my velocity ratio now, you can see it here, velocity ratio is OB over what? AB. And we have arrived at 1 over sine theta to be equals to OB over AB. So we can say that velocity ratio here is equal to 1 over sine theta. So anytime you're asked to find the velocity ratio of an inclined plane and the angle of inclination is given, you do not need any other parameter to calculate the velocity ratio. What you just need to do is to take the reciprocal of sine of the angle that is given. So next, we'll move over to the screw. So the second machine is the screw jack. Now the screw jack is a very simple machine that is used in lifting maybe a car where you want to lose a particular 40 tire from a car or a vehicle. You use this very simple machine called a screw jack to lift the car and you can lose out your tire. Now this machine, we can calculate its velocity ratio just as we did to that of the inclined plane. We will follow the formula for that, and the formula is velocity ratio is effort distance over load distance. Now in this particular device called the screw jack, you discover that the screw jack has what? The handle, which is called the tummy bar. Then it has thread. These teeth are called thread, and the gap between two threads is what we call a pitch. Now when you are using the tummy bar to lift a load, what you do, you simply apply a force on the tummy bar. This force applied on the tummy bar is to rotate the tummy bar through a circle. Make this tummy bar to turn through series of circles. Now, if this tummy bar turns one complete circle, these spindles, the thread here, there will be increase in the number of thread by 1. So that it now implies that the load that you are trying to lift has moved a distance that is equal to the distance between two threads, which is called 1 pitch. So by the time this tummy bar turns through one cycle, the load must have moved a distance that is equal to distance between two threads, which is equal to 1 pitch. We can write that the velocity ratio of this machine now is equals to effort distance is the length of the circle that was turned, that length of circle turned by the tummy bar. And for each circle turned by the tummy bar, you have 1 pitch. So we are saying that effort distance is equals to circumference of the circle of one circle turned by the tummy bar divided by load distance is going to be equal to the pitch, which is the distance between two threads. In that case, we see that velocity ratio is equal to, what is circumference of a circle? In mathematics, circumference of a circle is given by 2 pi r. Remember that this r now represents the length of the tummy bar. So we are going to write 2 pi r. That is the circumference of the circle that was turned by the tummy bar, divided by pitch, we use p, where our r is equals to what? Length of the what? Of the tummy bar, and p is equals to what? Pitch. We have told you what pitch is. Distance between two threads. So velocity ratio of this machine called the screw jack is equals to 2 pi r over p. So we'll go over to the next machine now. The next machine is wheel and axe. Third machine, wheel and axe. So if you look at this machine here, it has the wheel, which is this, and this other one is called axe. So what happens is that you apply a force here. Force is applied here. This force will turn this wheel through series of what? Circles. As this one is turning through a circle, this axe here is also rotating, making a circle as well. Therefore, we can write our velocity ratio, that velocity ratio VR is effort distance over what? Load distance. That is the formula for velocity ratio. Then we can look at this circle here. Let's bring the two circles out. So this one represents the big circle. Then this is the small circle. So this is the small circle. The small circle represents the axe, while the big circle represents the wheel. So we are going to look at the radius of the two. From here to this place, we give you small r, which is radius of the axe. Then from this point to this place, we give you big what? R, which is radius of the wheel. So we are now going to substitute into our formula that VR, velocity ratio, is equal to, what is the distance moved by the effort? Distance moved by the effort is equal to the circumference of the circle turned by the wheel. And the circumference of the circle turned by the wheel is equal to this 2 pi big R. Then the distance that the load is going to move, remember this is the load, by the time this turns through 360, this one will also rotate and turn through 360 as well, will be equal to, so the circumference of the axe is 2 pi small r. So by the time you look at this, 2 pi can cancel 2 pi, then we have that velocity ratio is equal to big R over small r. So this is the velocity ratio of what? Wheel and axle, where the big R represents the radius of the what? The big circle, which is the wheel, and the small r is the radius of the small circle, which is the axe. So the next one now, we'll go over to the fourth one, which is the wedge. The wedge. And what is the wedge? The wedge is a machine that utilizes two inclined planes. Anyway, try to understand this. A good example is the axe used in cutting firewood. The axe used in cutting firewood is called a wedge. How does it work? When you hit the axe on the firewood, it tries to separate the wood apart, so thereby cutting it. So what you discover is that from here to here is called the thickness of the what? Of the wedge. Then this is the slant height of the edge. So if we use x0 to represent the thickness and use x1 to represent the length, the slant height of the wedge, then we can write that velocity ratio. Remember, velocity ratio is effort distance over what? Load distance. So we can write that velocity ratio is, what is the effort distance when you are using this machine to do work? By the time you put the wedge inside the firewood, you discover that the effort you've applied is equal to x1, because this is the one that is going into the firewood, is this part. By the time this part goes into the firewood, it now break the firewood, make the firewood to move apart. In that case, the distance that the load has moved is equal to the thickness of the wedge. So we can write that load distance is equals to x1. Effort distance is x1. Load distance is x0, which is equal to, what is x1? x1 is slant height of the wedge divided by, what is x0? x0 is thickness. So this is the velocity ratio for wedge. You use slant height divided by the thickness of that wedge. So the next one is pulleys. A pulley is a machine that uses what is called groove. So let me draw it and illustrate. This machine is pulley. Now, in a pulley system, when we have what is called block and tackle system of pulleys, you discover that is a sort of this kind of arrangement. What is applied here, then this load moves a distance. So by the time you move this effort, you discover that the velocity ratio is equal to the number of pulleys. So it's very easy to use. This one is very simple. That if I have, what's the velocity ratio of this particular arrangement? VR will be equals to 1, 2, 3, 4. So I don't need any other stress. And the velocity ratio of the machine is equal to 4. You can now see that we are now able to arrive at the following formula. Say 1, for an inclined plane, we've arrived at different formulas for what? Velocity ratios of different machines. You can see that the inclined plane, the velocity ratio is 1 over sine theta. The screw, the velocity ratio is 2 pi r over pi. Wheel and axe, the velocity ratio is r, capital R over small r. The wedge, we have the velocity ratio to be, velocity ratio is equal to slant height of the wedge divided by the thickness. Then pulleys, the velocity ratio of pulleys talks about number of what? Pulleys. Number of pulleys. If it is 4, the velocity ratio is 4. If it is 2, the velocity ratio is 2. And so on and so forth. So we've come to the end of this section. In the next video, I'll be telling us how to use these formulas in solving problems. So when you have a problem, how to apply all the formulas you've known so far, starting from formula for mechanical advantage, velocity ratio, and different velocity ratio formulas that you've already known, how to apply it in solving problem, and also efficiency, as we've also discussed. So all these will be put together in solving problem in the next video. And also, do not forget that if in any of this machine it happened that there is no friction, if it happened that there is no friction in the machine, if in the question says that the machine is frictionless, that is no friction in such machine, you can also take it that the mechanical advantage of that machine will also be the same as what you have gotten here. So assuming that there is no friction in all the machines we have here, we could also establish that velocity ratio, that's what we said in the previous video, is equals to MA when there is no friction. In that case, if there's no friction in an inclined plane, mechanical advantage automatically becomes this, and so on and so forth. Thank you for watching the video to the end. Please do well to like this video, subscribe to this channel so that you'll be the first to get notification of any video that I drop on this channel. Please share with your friends. If you have any question, go ahead, drop your question at the comment section. I do appreciate my student from KDGA. Please do well to go through this video, as it is going to help you understand this topic better. And the next video will be on the way. Thank you.